In this section, we're going to deal with hypothesis testing when we don't know the population standard deviation. So let's look at an example. An electronics technician says that the mean repair cost for a damaged television is less than $100. You went to test this claim. You find that a random sample of 21 televisions has a mean repair cost of $99 and a standard deviation of $12. Assume the population is normally distributed. At the alpha equals 0.05 level of significance, test the claim and interpret your conclusion. Okay, so let's just write down some of the information we know. We know our sample size is 21, and this sample has a mean repair cost. So because this mean repair cost is referring to the sample, that's X bar is equal to 99. And again, the standard deviation is referring to the sample, so that's S is $12. Okay, so just like with confidence intervals, if we do not know the population standard deviation, or sigma is unknown, then we use a t-test, okay, just like we use the t-interval. Okay, so let's follow our 5 steps. We're going to state the null and alternative hypothesis. So I'm first going to set up the alternative because that's what I'm going to be testing. Okay, he says that the mean repair cost for damaged television is less than $100. Okay, so I want to test that mu is less than $100. Make sense? So then I do my null is the complement or opposite of that mu is greater than or equal to 100. Again, the null always has the equal sign. Okay, and my claim is here in the alternative. Okay? So my test statistic, I'm going to use a t-test statistic. So I'm going to go to my calculator, turn it on. I'm going to go to stat, over to test, and the very second one is a t-test. Okay, if I had put all the data in, I would choose data, but I don't, so I go over to stats, hit enter. Okay, now mu naught is what I'm assuming to be true. Okay, whatever's in your null hypothesis. So I'm assuming that to be 100. Enter. My X bar is 99. Enter. My standard deviation for the sample is 12. That's my S. My sample size is 21. And what I'm testing in the alternative is that it's less than 100 or less than that mu naught that I put in. So I choose less than. And I then choose calculate. Okay, so my t-test statistic is negative 0.38. I'm going to go ahead and write down my p-value here as well. And my p-value is 0.3533. Okay. All right, so now let's draw our critical region. Okay, so our critical region is a t-test, which looks similar to the normal, right? My zero's right here in the middle. So is it left-tailed, right-tailed, or two-tailed? Remember, you always look at the alternative here and to look at which way it's pointing to determine if it's left-tailed, right-tailed, or two-tailed. It's pointing to the left, so this is a left-tailed test. So I need to look up my critical value of t in the table that's provided. Now, in order to look it up in the table, we do need the critical value. Or I'm sorry, the degrees of freedom. The degrees of freedom is equal to n minus 1. So in this case, it's 11 because n is not 12. N, right, is 21. So my degrees of freedom is 20. So when I go to the table, I look at the one-tail area of 0.05 because alpha is 0.05, and I go down to 20 degrees of freedom, and you should see 1.725. Okay, so remember, this area right here is my rejection region. So if my test statistic falls there, I reject. Okay? So my test statistic is negative 0.38. Whoops, I forgot to put my negative. This is negative 1.725. So my test statistic is negative 0.38. So if this is 0, here's my 0, and this is negative 1.725, negative 0.38 is going to fall somewhere right here, right? So I'm going to go ahead and draw that in. Okay, that's my t, negative 0.38. So the question is, does it fall in this rejection area? No, it does not. Okay, so does it fall in the rejection area? No. That means we do not reject H naught. Okay, if we say no, we do not reject the null, H naught. If it said yes, then we do reject. Okay, that's the critical region method. And then looking at the p-value, we want to know, is the p-value less than alpha 0.05? So the question is 0.3533 less than 0.05? And of course, no, it is not. So again, my answer is no, which means I do not reject H naught. You only reject, okay, we only reject H naught if the p-value is less than alpha. Okay, so this right here, we only reject H naught if our p-value is less than alpha. 0.3533 is not less than 0.05. If you're not sure, when you compare decimals, just add the zeros and look at the numbers. This number is clearly bigger than this one, right? Make sense? Since we do not reject H naught, our conclusion is at the 5% level of significance, okay, here we say we either do or do not have enough statistical evidence. Since we did not reject, now remember, in Newton, it will say fail to reject. This means the same thing. I use the words do not reject just because my no's all go together here, okay? No, it was not less than. No, it did not fall in the rejection region, so I do not reject. When I do not reject, then we do not have enough statistical evidence, okay? If we rejected, we do. We do not have enough statistical evidence to conclude that, now I go back up to the problem to see what I was testing. I was testing, see this word that? That's what you're going to look for, okay? And I'm going to follow that. I do not have enough evidence to conclude that, and then I'm going to, what I have highlighted here is what I'm going to put in my conclusion. The mean repair cost for a damaged television is less than $100. That the mean repair cost for a damaged television is less than $100. So we actually do not support his claim, right? We don't have enough statistical evidence to support his claim that it's less than $100. Make sense?